Today in this video we'll learn about what linear regression is. It is a very interesting topic, so let's get right into it. Firstly, let's start with a line, right? First, to understand an advanced topic, you need to understand the basics first. So we all know what a line is, right? It's just a group of points pointing towards a specific direction. Now, what does a line have? In terms of the slope equation, we are talking about this. A line has a slope and then a y-intercept. Y is equal to mx plus c, where m is the slope and c is the y-intercept. So let's say I draw this on the xy plane and this is my line. So the slope is how y changes with respect to x, and then the y-intercept, which is also called bias in machine learning, is the initial value of y when x is equal to 0. So this would be the y-intercept, and then if we take 2 points and use the formula, and then let's call it, why is it acting out? If we take 2 points and then call it x1, y1, and then x2 and y2, and subtract it like this, y2 minus y1. You can take any points, just keep in mind that the order should be the same. Then we get the slope formula. It's also called delta y by delta x. So that's how a basic line works. Hope you're familiar with this topic. So what is linear regression? Let's suppose we have this points. Okay, focus on this image right now. Okay, so when you look at this image, you clearly see a pattern going on, right? Like, you think if this is how the data is scattered, the next data could be here, here, and then here and here. You kind of predict, your brain is predicting. So we could draw a line like this, right? So linear regression is just with the help of all of these dots or points, we predict where the future points will be, the points which we do not have data for. I'll explain this practically, so don't worry if you don't understand this. So this is how it looks like when Google Colab produces it. I gave it a code to run linear regression. So this is how it looks. Look, this is the regression line. So look, but we aren't predicting anything here, but this is what it's assuming the regression line to be. So the next thing is, let's take this data set. Now we will use linear regression to its test. Let's take this data set. This is a 2D linear regression. So we have this data set where x is the hours studied by a student for a test, and then y is the mark the student achieved. So let's hop on Desmos. So here I have plotted all of this points in Desmos. Now you clearly see that there is a line. There should be a line between like this 0,28 and all the way above to 1197. So let's click here and boom, we have linear regression working. Now you'll see that this is not exact, but it kind of predicts. So now the highest I went here was 1197. Now I can predict how much a student should study. Like if I want to get 100 marks, how much should I study? So according to linear regression, I should study 11.9 hours. So that's how it goes. So this can also be used the other way. If I study for, let's say, 2 hours because I'm very lazy, how much mark will I get? Let's see. So where's x? Oh yeah, so here, look, how much mark will I get? I will get 42.27. Not good, right? So that's how linear regression works. We predicted the data for something we did not have. I did not have the data for how much mark would I get if I only studied for 2 hours. Here, look, I did actually, but it is a bit different from the actual data, so this is just regression. Let's plot it for a data point we don't have. Let's say we have, I studied for 2.5 hours, then I will get 45 marks. Now you need to keep in mind that the linear regression predictions aren't exact. They will have errors because look, there's this gaps between the actual points and the line, so there will be errors. We try to minimize errors, but they will happen, but it is almost accurate. Learn that. So the next thing we'll learn about is linear regression on 3D. So I plotted this 3 points. Firstly, we plotted in the x-axis how many hours a student studied, and in the y-axis we plotted how much the student was present in the class in terms of percentage, and then on the g-axis we collected the test scores, like the final output. So this is how the data looks. I have rotated it through all directions so you can kind of get a feel of what it looks like from the top view, and when it almost looks 3D, but you gotta understand that linear regression works even on 3Ds. So here, look, this would be the linear regression, but you cannot imagine it to be a line but rather a plane. So the plane would be tilted like this, and then that would be your linear regression in 3D. In 2D we have a line, but here we have a plane cutting all of these points almost accurately, but there is gonna be some error. So hopefully I explained linear regression to you. Thanks for watching this video.